Welcome to our Black Hat Maths class, and these are the triangles that we have. Two triangles combined into one, and then we have SQR, so that's theta, and SRQ, that's also theta, and then QR is equals to SQP, and then we're solving for that angle and that side. So what we have to do is we check all the triangles. That's SQP, that's the angle, and QSP, that's the right angle, 90 degrees. And the next thing that we do, SP is equals to K, so that is the K that we have, and K is equals to P sine theta over 2 sine theta. And the next thing that we have to apply is in triangle, we have in triangle QSP, we have to solve for K, so K is on that other side of the same triangle. So we have to move from that side to the other triangle where we have P and SQR, and then that's the SQR, and then QS is the bridge from which we have to cross from Q. It's gonna be QSP to QRS. So we're gonna move from triangle QSP to triangle QRS. So those are the triangles that we're going to move from using the QS. So QS is the part that shares, so we're gonna use that as equivalence to the bridge that we're going to use to cross to the other side. So we have in triangle QSP, we have sine rule applied. So the sine rule will say that we have sine P over QS, and then we need to know what angle P is. So angle P is 180 degrees minus theta 90 degrees. So it's gonna be 90 degrees minus theta. So because we have another 90 degrees known, so it's all equivalent. So 180 minus 90, that's going to be 90 degrees, and then 180 minus theta is going to be minus theta. Okay, so we have 90 degrees minus theta, negative terms, theta is negative theta, and then we have sine, which is sine brackets 90 degrees minus theta all over QS. And on the other side of the same triangle, where we need to find K, so the opposite side will be the angle, which is sine theta over K. So sine theta over K will give us cross multiplying that, so that will be QS multiplied by sine theta. QS multiplied by sine theta gives us K multiplied by sine 90 degrees minus theta. So multiplying both sides by sine theta, and then multiplying the other side also by sine theta, then we'll have to cancel. So our QS, let's use the cast rule so that we know what sine 90 minus theta will look like. 90 degrees minus theta. Okay, so that's 0 degrees 360. That will be 270 degrees, and that will be 180 degrees. So minus, I said plus, it's supposed to be minus, so minus and plus for sine gives the same answer, no problem for that mistake. So QS is equals to K cos theta all over sine theta. So that's QS. So I like it in a fraction like that, but you can also use cos theta over sine theta to give you K cot theta. So that's the most preserved way to write it. And then from there we have to move to another triangle. So QS is going to be K cot theta in a simplified version, but you can always change cot theta to cos theta over sine theta. So I'm moving to another triangle QRS, and then that triangle there, you can see that we still have QS as part of the triangle. So moving in triangle QRS, we need to find the angle ACE, and that, because remember the other sides as, so in triangle QRS, we have, okay, QRS we have in triangle QRS, we have that P opposite that part of the angle. So that part there will mean that we have angle S. So angle ACE will be QSR, which is angle S, is going to be remember we have 2 theta there, so that one will be 180 minus 2 theta as our angle for S, QSR. And then we have 180 degrees minus 2 theta. So again, using sine rule, so that would be sine that over that and sine that over that. So sine theta over QS and sine 180 minus 2 theta over P. Okay, that's 180 degrees minus 2 theta. So it's sine 180 degrees minus 2 theta. So all over, so that will be all over P. And we also have, okay, that's P. We also have sine theta. So that will be sine theta all over QS. So QS is the part that we solved before, if you remember. And then we need to solve for that. Sine 180 minus 180 goes back to sine, that's positive, so it's going to be sine 2 theta. So that sine of double angle all over P is equals to sine theta over QS. So this goes to the answer now. So now we have to break the sine 2 theta. So dissolving that or expanding that will give us 2 sine theta cos, sine theta cos theta. So we're expanding sine 2 theta, all that over P. And then from there we have sine theta, so that is sine theta over QS. So remember what QS is. QS there, QS is K multiplied by cos theta over sine theta. So we put K there, cos theta over sine theta. So that's a fraction. So you know that that will give us sine theta all over K multiplied by, so we inverse the fraction, the numerator becomes the denominator, denominator becomes the numerator, and then that would be sine theta over cos theta. And then we can just check through the simplification part. When looking at the simplification part, we can see that now we have 2 sine theta cos theta all over p is equals to sine theta multiplied by sine theta as well. So that's the previous expression. So all over k cos theta. So the cos become the denominator. And then because we have on the both sides multiplication, so we can cancel. So we have 2 cos theta over p, over p to give us sine, to give us sine theta over k cos theta. So with those two equations on each side, so what we do, we multiply both sides by cos. So that would be 2 cos theta multiply both sides of the equation by cos theta. So that would mean we have 2 cos theta multiplied by cos theta all over p, and that gives us sine theta. So sine theta, now we'll have to divide by cos, sine theta over cos, and then sine theta, that's supposed to be k, sine theta k cos theta, and then multiplying both sides by cos theta, that cancels that, and then we have 2 cos squared theta. Remember that we multiply both sides by cos theta, so 2 cos squared theta multiplied by k is equals to p sine theta. So that's when we cross multiply. From there, what we do, we divide both sides by 2 cos squared theta, and then cancels out. So now we have the value that we want, which is k. So k, that cancels out, so we have k is equals to p sine theta over 2 cos squared theta. So that's exactly what we wanted to prove, and that's step 1, step 2, step 3, step 4, step 5, step 6, and step 7, arriving us on the answer. So thank you so much for watching, and don't forget to subscribe or follow for more mathematical problems and solutions. Thank you.